Alright, still looking at some more examples of the indeterminate form. Again, if you were to do the direct substitution here, if you directly substituted in 0, of course that would give you 1/4 minus 1/4, which is 0 on the top, and then you also would have 0 on the bottom. So, got to look at a way to fix this situation. Now, we've already looked at factoring and canceling out factors, the rationalizing. This example doesn't fall into either of those two categories. What you're dealing with here is a complex fraction. Remember, fraction inside fraction. So what you've got to do is simplify the complex fraction. One thing that you need to remember, of course, this x would be understood to be over 1. So if you were picking a common denominator for all of this, your common denominator is going to be 4 times x plus 4. So like this 4 would not count as the same thing. So we're going to go through and we're going to multiply all of these terms, top and bottom, by 4 times x plus 4. Okay. Now still continue to write your limit, because remember we're not doing the direct substitution yet. Alright, so with the first term, what will happen is your x plus 4's are going to cancel, so that just leaves you with 1 times 4, which is 4. Okay, here the 4's are going to cancel. Now this being subtraction, you got to be careful. This is a -1. So what you're going to have to distribute is a -1, so that's going to give you a negative x minus 4. If that had been a plus sign, then this would just stay x plus 4 over here. Now, nothing's going to cancel here because all you have in your denominator is a 1. Again, don't multiply this out. Just leave this as 4x times x plus 4. If you multiply it out, you're just going to have to turn around and undo what you just did. Okay, simplifying what I have in my numerator, my 4's are going to add out, so I'm left with negative x over 4x times x plus 4. And then I'm going to be able to cancel out the x's. So I'm left with -1 in my numerator, and then 4 times x plus 4 on the bottom. Now try the direct substitution. So that would just end up being 4 times 4, which is 16. So see, when you do your direct substitution this time, you don't get the indeterminate form. Now remember what I told you a while ago? If you're unsure, when is it time to do direct substitution? If you're doing it too early, you're still going to get 0 over 0, which means you got to keep going. You got to do some more simplifying of some type before you do direct substitution. All right, another example. Okay, now first of all, some of the notation that you're seeing here, this is not just simply x, this is delta x. So your little triangle shape is referred as delta. This is just a variable, but delta x, like you have here and here, is different from the x's that you have here and here. Okay. Now, if you do direct substitution, if you put the 0 here and here, work it out, you will get 0 over 0. Okay. So what we've got to do is just some algebra here. First thing is you're going to want to write this down twice and multiply it out. Okay. Alright, so if I FOIL this out, x times x, and then x times delta x. Now this x, is not the same thing. So x times delta x is just x delta x. And then same thing here, delta x times x. And then delta x times delta x would be delta x squared. And then bring down the minus x squared over delta x. Okay, next. Your x squares are going to add out. You will be able to combine these two together, so 1x delta x plus 1x delta x is 2x delta x. And then bring down the plus delta x squared. Alright, your next step is in your numerator. Both these terms have a delta x. It's the greatest common factor, so we're going to pull the delta x out front. Okay, so if you take the delta x from this term, that just leaves you with 2x. Now, since this is delta x squared, that means you have two of those, so you're pulling one of them out, but you're still left with one. Then, your delta x's are going to cancel. So now I have just 2x plus delta x left. Now do your direct substitution. Now you're substituting the 0 in for the delta x. So you would have 2x plus 0, which is just 2x. Now I know that's not, of course everything else we've been doing, we've been getting a definite number, but that's just how this works, because delta x is just a variable. They could have easily just written this as x plus y, and it would have all still worked out the same way.